Welcome back everyone, Patrick here, moving on to the next question dealing with quadratics. So what we have to do, we have to determine how many x-intercepts each of these quadratics has, and then we have to verify by actually finding the x-intercepts with the quadratic formula. So notice that all of these here are in vertex form. So we're first going to determine how many x-intercepts there are, and then we're going to actually find them with the quadratic formula. So when a quadratic is in vertex form, to find out how many x-intercepts there are, it's actually fairly simple. You just have to do a rough drawing on it because it's only going to depend on two things: where the vertex is, and then also whether the quadratic opens up or down. So notice here, the vertex is at 4 and 1. So if we plot that, 4, 1, that's going to be right here. And does this quadratic open up or down? Well, notice that we have an a value of positive 1 over here. So we know it's going to open up because the a value is positive. And so it's going to look like that. And we could tell from the drawing there how many x-intercepts are there. Well, notice it doesn't go through the x-axis at all. So for part A, there are none. And we're just able to get it with a simple drawing: where the vertex is and whether it opens up or down. Now, if it opened down, we'd be able to tell there would be 2 x-intercepts right there. Okay, and it actually, even more specifically, all that really matters is where the k value is, or the y value of the vertex. The reason why I said the k value here, because remember, vertex form, just in general, is like this, where this k value represents the y value of the vertex. And really, that's all that matters, because where the x value of the vertex is, or the axis of symmetry, it doesn't really matter, because you could take this, you could shift it over here, so the x value of the vertex would be different, but the y value, that k value, would still be the same. So more specifically, it matters what's the y value of the vertex, or the k value in the vertex form, and what's the a value, is it positive or negative. If you want, this is kind of like a side note here, you can take the vertex form. Remember, this is only for vertex form, what I'm about to write over here. And you could say, okay, is the k value positive? Is it 0? Or is it negative? And then from there, we can say, okay, is the a value positive, or is it negative? Okay, and then over here, it's not going to matter. I'm going to explain why. And then over here, is the a value positive? Is the a value negative? So you can make like a decision tree over here, and that will tell you, we're going to go through each of these cases, what the number of x-intercepts is going to be. Again, this is only for vertex form over here. So if the k value is positive, like it was here, and then the quadratic opens up, meaning the a value is going to be positive, then we know that there are none. There are no x-intercepts. If the k value is positive and the quadratic opens down, so that means the vertex is going to be like up here or up here, somewhere above the x-axis, it's going to be positive. The y value of the vertex is going to be positive. And if the quadratic opens down, then we know in any of those cases there are going to be 2 x-intercepts. Okay, let's be a little bit more specific here because I didn't write it, so I'll say no x-intercepts. Now, what if the k value is 0? Well, if the k value is 0, that's actually going to happen right here in part D. What does that mean? It means the y value of the vertex is 0, meaning that the vertex is going to be on the x-axis. Right? So there's going to be some kind of x value here for the vertex, but the y value is going to be 0, so the vertex is going to be somewhere on the x-axis, and it doesn't matter whether it opens up, whether it opens down, right? Up, down, whatever. There's only going to be one x-intercept in that particular case. So over here, K value is 0. It doesn't matter if the A value is positive or negative. If the K value is 0, then we know there's only going to be one x-intercept in that case, right? So that's going to be part D over here, one x-intercept. It means that the vertex is the same as the one x-intercept. Now, the last two cases, if the K value is negative, it means that the vertex is going to be below the x-axis. So let's say it's like right here. And if the A value is positive, well, then there's for sure going to be two x-intercepts in this case. Okay, but if the A value is negative, if the vertex is, again, or the K value is negative, meaning the Y value of the vertex is negative, meaning it's below the x-axis. So let's say over here, and it opens down, right? Or this one, let's say it opened down. Well, notice it's never going to cross that x-axis there. So over here, there would be no x-intercepts like that. Okay, so that ends up being the different cases for the vertex form for the number of x-intercepts. And so what we can do is let's go through each of these one by one and see what the case is. So notice the K value is positive. Here, the A value is negative. So there's going to be two x-intercepts for this quadratic right here. Right? If we were to plot this, the vertex would be -5 and +4, which would be like here, -5 and 4, and then it's opening down because the A value is negative. So it's going to go through two x-intercepts for sure. Okay, now what about part C? Negative K value, that's here, and then the A value is positive, so two x-intercepts for this one. Again, if you want to graph it, -1 and -3, that would be the vertex. Remember, it's -1 because we always switch this sign. And then it's a positive A value, a +5, meaning that the quadratic's going to open up. So two x-intercepts. For part D, we already mentioned how the K value is just 0, meaning there's only going to be one x-intercept for this one. And then 2x squared plus 3 over here. Notice that this is also in vertex form, by the way. This is like x plus 0 squared plus 3. So the vertex is going to be at 0 and 3. Whenever you have an ax squared plus k type of quadratic, the vertex is always going to be at 0 and the K value. So notice the K value is positive, which would be this. The A value is +2. So it's positive. So in this case, there are no x-intercepts. So there's none here. More specifically, the way this quadratic would look, we'd have a vertex at 0 and 3, and then it's opening up like that. Right? So from this, and then also from diagrams, whichever way you want to do it, I'm just kind of giving you different angles at which to look at this so you better understand it. We found the number of x-intercepts for each of these quadratics. We're going to have to actually find what they are with the quadratic formula, but finding the number of them, we were able to start with that. So let's actually find them now. So starting with part A, now in order to use the quadratic formula, what do we need? Well, we need the quadratic to be in standard form. Another thing that we're going to be doing is to find the x-intercepts. What do we have to plug in? We have to plug in 0 for y. So we have to take this quadratic, plug in 0 for y, and then solve for those x values right there. Okay, and to do it with the quadratic formula, we got to make sure that this quadratic here is going to be in standard form. Remember, we need, actually, let me write it up here. So we need, if we have a quadratic equation where the quadratic is in standard form, right, plugging in 0 for the y value, then the solution to this equation is going to be -b plus or minus square root of b squared minus 4ac all over 2a, like that. Okay, but again, in order to use this, the quadratic has to be in standard form, so we have to expand this. So again, plugging in 0 for y, we'll have 0 equals x minus 4 squared plus 1, like that. So if we expand this, x minus 4 times x minus 4 will give us x squared minus 8x plus 16 plus 1, x squared minus 8x plus 17, like that. Okay, and now notice we can plug in, this is in this format, so notice the a value is 1, the b value is -8, the c value is 17. So plugging in these parameters into the formula, we'll end up with -8 plus or minus -8 squared minus 4 times 1 times 17 all over 2 times 1. Now remember, we got from the diagram that there's going to be no x-intercepts. So watch what happens here. It's going to be interesting. What would happen here is we would have, this would be +8 plus or minus 64 minus 4 times 1 times 17 would give us 68. That's going to be over 2. So we'd have 8 plus or minus root -4. And notice the problem? You can't square root a negative number like that. And so getting to this point here, we proved that there's going to be no x-intercepts. Whenever this expression, which is called the discriminant, by the way, we will talk about it separately, not in this video, but whenever this over here ends up being a negative, like we got over here, whenever the discriminant is a negative, because we can't square root a negative number, there ends up being no solution to this. So there ends up being no x-intercepts. Okay, so if you do work with a quadratic that was already given to you in standard form and you're finding the x-intercepts, use the quadratic formula for it. If you get here, it means that there's no x-intercepts. So we're able to show that with the quadratic formula. So that makes sense. Now, what about the next one? Well, the next one, we should expect to get 2 x-intercepts. So again, first thing we got to do, expand everything. So if I take that, -2, x plus 5 squared, x plus 5 times x plus 5 would give us x squared plus 10x plus 25 plus 4, -2x squared minus 20x minus 50 plus 4, like that. This would be -2x squared minus 20x minus 46, like that. So this quadratic, let me just make sure that it is correct. Yes, it looks fine to me. So this quadratic and this quadratic, they're actually the exact same thing. Okay, and to find the x-intercepts, what do? Well, we plug in 0 for y, so we'd end up with the quadratic equation equaling 0 equals -20x squared minus 20x minus 46. So notice here, for this quadratic in standard form, the a value is -2, the b value is -20, the c value is -46. And then taking these parameters, plugging it into the formula, we'll have x equals negative, and then the b value is -20 plus or minus -20 squared minus 4 times the a value -2 times the c value -46. Give me a sec here. Yes, all over 2 times the a value -2, like that. So what happens here, we'll have 20, +20, plus or minus, now -20 squared is 400, and then we'll have 8 times -46, right? Negative, +8, and then times a negative, so we're going to end up with a negative over here. And so 8 times 46 would give us what? 368, like that, and that's going to be divided by -4. And so when you do this algebra further, let's do it up here, we'll end up with x equaling 20 plus or minus 400 minus 368 would give us 32 all over -4. So notice that because we got a positive value here, because that discriminant is positive, the square root of a positive number is going to be plus or minus. Hence, we're going to get 2 solutions. So whenever this b squared minus 4ac, whenever that discriminant is positive, you're always going to have two solutions to the equation, or if you're looking for the x-intercepts, you're going to have two x-intercepts. So it makes sense with what we found before as well. Now, this can simplify, actually, so the root 32, again, your teacher may go through simplifying radical expressions, or they may not. If they do, you could just follow this. If they don't, if they just allow you to get the two decimal values, you can do that as well. You could skip these steps. But in case they do want you to simplify, this would be root 16 root 2, which would be 4 root 2, like that. So we'd have 20 plus or minus 4 root 2. 4 root 2, root 32, those are the exact same thing. If you plug them both into your calculator, you'll get the same. So we'll have 4, take out a 4 from the top, plus or minus, there's like a 1 left here, and then we got the root 2 left, over negative 4, notice this, and that cancel out. And so we're just left with a negative 1 at the bottom. We can bring the negative up, and so we end up with negative 5 plus or minus root 2, like that. So there's two solutions. Either x equals negative 5 plus root 2, or x equals negative 5 minus root 2. So this would be negative 5 minus root 2, like that, or negative 5 plus root 2, like that. So those right there end up being the two x-intercepts as exact value. And then also, if you want the decimals, those would be the two decimal values right there. Right, so two decimal values here, two x-intercepts, those are the two x-intercepts for that quadratic. So it makes sense. We got two x-intercepts, and then we also mentioned that there will be, just from looking at the diagrams, where the vertex is positioned and with the quadratic opening down as well. Okay, so same process now for part C. What we got to do, again, we have to expand this quadratic, put it in standard form, so we'd end up with 5x plus 1 squared would give us x squared plus 2x plus 1 minus 3, like that. Then we could expand this, so 5x squared plus 10x plus 5 minus 3, so we'd end up with 5x squared plus 10x plus 2, like that. Let me just make sure. Yes, it looks all good to me. So this quadratic in standard form and this quadratic in vertex form, they're both the exact same thing. And so when we're finding the x-intercepts of the quadratic, we plug in 0 for y, so we're solving the equation 0 equals 5x squared plus 10x plus 2. So we could plug it then into the quadratic formula. A is 5, B is 10, C is 2. Plugging these in here, we end up with x equaling negative 10 plus or minus 10 squared minus 4 times the a value of 5 times the c value of 2, all over 2 times the a value of 5. Like that. This is a 5 over here. Looked like a 3 a bit. Yes, looks all good to me. So from here, we'd end up with negative 10 plus or minus 100 minus 40 all over 10. So we end up with negative 10 plus or minus root 60. And that's going to be over 10, like that. Now, the root 60, give me a sec here. Yes, so the root 60, that actually simplifies. So let's rewrite this over here. 10 plus or minus root 60 over 10. The root 60 we could simplify into, we could divide this by 4. So we go root 4, root 15 by a rootable number. So we end up with 2 root 15. And then the 15, we can't divide that by 4. We can't divide that by 9. Can't divide it by a rootable number. And so this would be the simplified radical. So root 60 to root 15, if you plug those both into your calculator, they're both the exact same thing. So plugging this in here, negative 10 plus or minus 2 root 15, and then notice, what can we do? We could take out a 2 from both of these. So if we take out a 2, we'd be left with negative 5 plus or minus. This 2 came out, so we're just left with the root 15. There's like a 1 left in front. Over 10, 2 goes into 10 5 times, like 1 over 5. And so the 2, or let's put the solutions together for now. So negative 5 plus or minus root 15 over 5, like that. Again, your teacher may not expect you to have to simplify this expression, but that's what it simplifies to. This and this are the exact same thing. You would get the same decimal values, but this here is simplified. We simplified that radical expression. So the 2 x-intercepts, and by the way, notice how we got 2 x-intercepts, which makes sense. That's what we were expecting to get because we have a positive value under the square root. That discriminant is positive, so we get 2 different solutions. So x can either be negative 5 plus root 15 over 5, or x can be negative 5 minus root 15 over 5, like that. So either of those work. And if you want the decimal values, those would be the 2 decimal values right there that you would get for this quadratic right here. Those would be the 2 x-intercepts and decimals. Okay, and it makes sense because we were expecting to get 2 x-intercepts. Let's move on to the next one. So the next one, we're only going to get 1 x-intercept. And it's easy to tell because the vertex here would be 2 and 0, which is an x-intercept as well. Right? In this kind of case where that k value is going to be 0, the 1 x-intercept and the vertex are the exact same thing. So we should, when we do the quadratic formula, expect to get 1 solution, and it should be an x value of 2. So let's see if we do get that if we use the quadratic formula. So for this, we're going to have to expand everything. So negative 3x minus 2 squared would be x squared minus 4x plus 4. Negative 3x squared plus 12x minus 12. Like that. Right? Yes. And so to find the x-intercepts, we're plugging in 0 for y. So this is the quadratic equation that we'd be solving. A is negative 3. B is positive 12. The c value is negative 12. So let's see what happens here. We'll have x equals negative the b value 12 plus or minus b squared, which is 12 squared, minus 4 times the a value negative 3 times the c value of negative 12, all over 2 times negative 3. You're going to see something interesting happen here. Negative 12 plus or minus, this would be 144. Well, what do we get here? Negative 4 times negative 3 is positive 12 times negative 12 would give us minus 144. All over negative 6. What do we get under the square root? 0. And so whenever you have the case of 1 x-intercept, you're always going to get a 0 under the square root. So whenever that discriminant, b squared minus 4ac, is 0, there's only 1 solution to the equation, or 1 x-intercept to the quadratic that you're working with. So remember, there's only 3 cases. If it's positive, 2 solutions. If it's 0, like in this case, there's only going to be 1 solution. If it's negative, then there's no solutions. Those are the 3 different cases for this discriminant, b squared minus 4ac. That's the name of it. If you want to look ahead to lectures, or if you want to Google about it, that's the name of that expression in the quadratic formula. And so in this case, we end up with plus or minus 0. We can get rid of that. It's just negative 12 over negative 6, which gives us positive 2 as expected. I erased it, but we said that the vertex would be at 2 and 0, which is also the 1 x-intercept. Okay, so everything checks out. Everything makes sense with what we got before. And then finally, part E, this one's going to be easy. It's already actually in standard form. It's both in standard form and vertex form here, right? Because this is like 2x plus 0 squared plus 3. A quadratic that's in this format, it's both in standard form and vertex form at the same time, right? Because it's just that x plus 0 right there. And we already know that the vertex is at 0 and 3. And it's opening up because of that positive a value. So we know that there's not going to be any x-intercepts. But let's verify with the quadratic formula. If there's not going to be any x-intercepts, we should get a negative under the square root. So let's see if we do that. Notice the a value. So first off, the equation, because it's already in standard form, it's 2x squared plus 3. So the a value is 2. The b value is 0 because it's like 2x squared plus 0x plus 3. If there's no bx term here, the b value is just 0. So c is 3. Plugging these parameters into here, we'll have negative 0 plus or minus, the b squared is 0, minus 4 times the a value of 2 times the c value of 3, all over 2 times the a value of 2, which would be, this would just be 0 over here, so we'll have plus or minus root 0 minus 4 times 2 times 3 would give us 24, all over 4. Well, notice what happens. We get negative 24 under the square root. And you can't square root a negative number. So from there, we know there's no solutions to this quadratic equation, right? So over here, because we got to that point, because that discriminant is negative 24 in this case, there are no solutions, meaning there's no x-intercepts. And then you could even try to isolate it here. So like if we brought the 3 over, it'd be negative 3. Then we divide both sides by 2. And then what do? Square root both sides to get the x by itself. Again, can't square root a negative number. So even if we try it that manual way, it's not going to work. Now, if it was minus 3, then we would get 2 solutions, because then the vertex would be at 0 and negative 3, which would be down here. And if it opens up, well, now it changes the game because there would be 2 x-intercepts. This would end up being positive, so we would get 2 different solutions, right? This negative 3 here would turn this into a positive 24, and the square root of positive 24 would have 2 solutions. All right, but because this k value is positive and because the quadratic opened up, there are no x-intercepts. We showed that with a diagram, and then we also verified it with the formula.